Hello everyone, welcome to another revision lesson yama cubic functions. So today sizokwenza questions, right? So ngaphandle kokuthi simoshe isikhathi, let us look at this question. We are given a function f of x is equals to x cubed minus 4x squared minus 11x plus 30. Izolo sibe ne-example with this exact same function, right? So ku 9.1 bathi use the fact that f of 2 is equals to 0 to write down a factor of f of x, right? So this is the factor theorem, where if f of k, the factor theorem states that if f of k is equals to 0, then x minus k is a factor of f of x, right? So in this case, x minus 2 is a factor of f of x, yeah? So f of x, x minus 2 is a factor of f of x, right? So now siyalapha ku 9.2, but calculate the coordinates of the x-intercepts, right? So we have x minus 2 as a factor of f of x. We can use this long division as a divisor to find the other factors, right? So ngizokwa x minus 2 as our divisor, and then here I'll have x cubed minus 4x squared minus 11x plus 30, right? And then I'll divide x cubed by x to get x squared, and then I'll multiply x minus 2 with x squared and subtract, and I'll have x cubed minus 2x squared, and then I'll subtract x cubed minus x cubed is 0, minus 4x squared plus 2x squared is minus 2x squared, right? And then I'll bring 11x down in that plus 30, and then I'll divide to minus 2x squared more x to get minus 2x, and then I'll multiply x minus 2 with minus 2x. I'll get minus 2x squared minus, that's plus 4x, right? And then I subtract minus 2x squared plus 2x is 0, minus 11x minus 4x is minus 15x, and then I'll bring down the 30, and then I'll divide minus 15x with x to get minus 15, and then I'll multiply x minus 2 with minus 15 and subtract. I'll have minus 15x plus 30, right? And then I subtract. I'll have minus 15x plus 15, which is 0. I'll have 30 minus 30, which is 0. Therefore x squared minus 2x minus 15 is also a factor of f of x, right? So x squared minus 2x minus 15 is a factor of f of x. Okay, so I'll use that to calculate my x-intercepts, right? Okay, and then here I'll just expand x squared minus 2x minus 15. It will be x minus 3 and it will be x minus 5 and x plus 3 equals to 0, and then x will be 2, or x will be 5, or x will be minus 3, right? So these will be the coordinates of my x-intercepts: 2, 0, 5, 0, minus 3, 0, right? And then say 9.3, calculate the coordinates of the stationary points. So I'll calculate the turning points and the point of inflection. right? To do that, I'll need to differentiate my function. So I'll have f prime x is equals to 3x squared minus 8x minus 11, right? To calculate the turning point, I equate this to 0 and then solve for x, right? Minus 8x here minus 11 equals to 0, and then I solve for x. If we factorize, sizothola x is equals to 11 over 3, or x is equals to minus 1, right? So now we need to calculate the coordinates, so we have to calculate the y values. So if we substitute 11 over 3 in our function, we'll get x, y is, if we substitute 11 over 3 in our function, y is equals to minus 400 over 27, which is minus 14.81, right? And then if we substitute minus 1 in our functions, y is 36, right? So the coordinates of my turning point is 11 over 3 and minus 14.81, right? And then the other one is minus 136, right? And then I'll have to calculate the point of inflection. To calculate the point of inflection, I'll need to calculate the second derivative, right, which is the derivative of the first derivative. So I'll differentiate this first derivative of f. So here I'll have 6x minus 8, right? And then to calculate the point of inflection, I equate this to 0 and then solve for x, right? X is equals to 8 over 6, or x is equals to 4 over 3, right? And then if I substitute 4 over 3 in my function, I get this will be 286 divided by 27, or I'll just say it's 10.59, right? So these are my critical points. So I have my x-intercepts and the turning points and that point of inflection, right? And then Lapo 9.4, they say I need to sketch the curve of f, show all intercepts and the turning points, right? So I'll need to also calculate my y-intercept by making x be 0. So if I make x 0 in that function there, I'll get y will be equals to 30. So the point 0, 30 will be the coordinates of my y-intercept, right? So now we can go ahead and sketch the function, right? We can go ahead and sketch the function. Okay. Right, so I'll have my x-intercepts at minus 3 and at 2 and at 5, right? And at 5. So these are my x-intercepts, and then my y-intercept will be at 30, and then my turning points will be at minus 1, and 36, right? And then my point of inflection will be somewhere here at 4 over 3 and 10.59, 10.59 4/3, and my other turning point will be at 11/3 and at minus 14.81, right? It will be somewhere there, right? So now all I have to do is to connect the dots. Okay, so my graph will look like that. So I have my turning point, I have my x-intercepts, I have my y-intercept, I have my point of inflection, and my other turning point. So this is the shape, and I have indicated all the critical points, right? And then we can go to 9.5. So 9.5, but for which values of x is f prime x less than 0? Remember, this is the gradient of f of x, right? So if you look at the shape or at the graph of the function of f, where is the function, where does this function have a decreasing or where is the gradient of this function negative, right? You'll notice that the gradient is negative where this function is decreasing. So that portion where the function is decreasing will correspond to f prime x less than 0, right? So from here to here, the function is decreasing. So the function is decreasing in this region, right? From here, it's decreasing from x equals to -1 to x equals to 11/3. So those values of x for which the first derivative of the function is less than 0 will be x greater than -1 but x less than 11/3, right? And then let us go to the other question. Let's first erase here. Okay. Okay, so we have another question here. It's also labeled question 9. But the function defined by f of x equals to whatever is sketched below, and then p and r are the turning points, as we can see in the graph. And then but he showed that a is equals to 1 and b is equals to -1, right? So I will use the given point to calculate the value of a and the value of b. Because we have two unknowns, we need two equations. So to get my first equation, I'll substitute this point p ku function yami. I know when I substitute -1 in my function, I should get -1 because of this point, right? So if I substitute -1 there, I'll have -1 cubed plus a times -1 squared plus b times -1 minus 2 should be equals to -1, right? So I'll have -1 plus a minus b minus 2 equals to -1. That -1 and that -1 will cancel, and then I'll have a minus b to be equals to 2. That will be my first equation, right? And then to get my second equation, I'll use the very same point but in a first derivative of the function. So if I calculate f prime x, I'll get 3x squared plus 2ax plus b, right? Notice ukuthi this point p but is a turning point. So because this is a turning point, we know ukuthi the gradient of this function is 0 at that point, right? So meaning f prime minus 1 should be equals to 0, right? Because at this point the gradient of the graph is 0. That's why we say f prime minus 1 is 0, right? So I'll substitute minus 1 where I see x in this f prime x equation. So I'll have 3 minus 1 squared plus 2a times minus 1 plus b is equals to 0. So I'll have 3 minus 2a plus b equals to 0. So from equation 1, I can see what b is equals to a minus 2 from equation 1, right? So wherever I see b in this second equation, I'll put a minus 2. So I'll have 3 minus 2a plus a minus 2 is equals to 0. So I'll have minus a plus 1 is equals to 0. So I'll have minus a is equals to minus 1, meaning a is equals to 1, right? And then if I substitute a 1 in this equation here, I'll get b is equals to 1 minus 2, right? Because lapha sithe b is equals to a minus 2, and then but then we know the value of a to be 1, so b will be equals to 1 minus 2, and then zothola ukuthi b is equals to minus 1, right? So yeah, that's how you do it. When you have two unknowns, make sure that you have two equations, right? And then sizoya ku 9.2, and then 9.2 but hence or otherwise determine the x coordinates of r. The x coordinate of r, so 9.2, now because we know what a is 1 and b is minus 1, we know what our function should be. F of x is equals to x cubed plus x squared minus x minus 2, right? So to calculate r is a turning point, so to calculate the coordinates of r, we will need to calculate the first derivative of x, right? This will be 3x squared plus 2x minus 1. And then to calculate the x coordinates, we know what we have to equate the first derivative to 0 and solve for x, right? So that is f prime x equals to 0, and then solve for x, right? I'll have 3x plus minus 1 and x plus 1, right? So I'll have x squared, yeah, right? So x will be 1 over 3 for x equals to minus 1. So I know what the point r is on the right hand side of the y-axis. So in the right hand side of the y-axis, my x is positive there, so I'll have to pick this point. Therefore x equals to 1 over 3 will be the coordinates of r, will be the x coordinate of r, right? And then 9.2, 9.3, but write down the coordinates of the turning point of h if h is defined by h of x is equals to 2 times f of x minus 4, right? So I have this turning point of f, right? So they want me to calculate the turning point of h, right, by multiplying the turning point of f by 2 and shifting it 4 units down. I can determine the turning point of h, right? So using the coordinates of p, minus 1 and minus 1, if I multiply this by 2, I'll get minus 2, and then if I shift this minus 2 4 units down, I'll get to minus 6, right? So therefore the coordinates of a turning point of H is minus 1, minus 6, right? This is the answer, right? They didn't specify which turning point you can use, or they just said calculate the coordinates of a turning point, right? It doesn't have to be both turning points. You can do the same with the coordinates of R. So if we know what the x coordinate of R is 1 over 3, and then to get the y coordinate of R, you'll say f of 1 over 3. This will be equals to, if you check your calculator and substitute 1 over 3 in that function, you'll get that the y coordinate of R is minus 59 over 27, right? If you say minus 59 over 27 times 2, you'll get to what this is minus 59 over 27 times 2 is equals to a negative 118 divided by 27, and then if you shift this 4 units down, it's equals to minus 226 divided by 27. So the other coordinate of the turning point of H can be 1 over 3 minus 226 divided by 27, right? So that is how you do it. Okay, so yeah, sizo jamala kule video. Feel free to ask if you have any questions. Okay.